Grayling are very common. They probably don't receive the love or the notoriety that they should.
Arctic grayling is in the family Salmonidae, which means that it's related to salmon and trout and whitefish, all the salmonid species.
There's a ton of other species, at least on the recreational side, that are usually much more popular than grayling.
If you're lucky and it's a sunny day, they might leap out of the water at a fly, just give you a nice fun fight on the line. But they're also important for native peoples that feed them to their dogs, and people do eat them.
In certain locations like the Chena River in Fairbanks, they are very, very popular species for rod and reel anglers. As well as in the smaller communities, they're very important seasonally for subsistence fishing. They're usually one of the first species folks capture, and to have fresh fish after a winter of eating dried food and grocery store food, and it can be a real treat for folks.
Some of my research is looking at how variable is the gene pool, how many populations there are across the landscape, what is the connectivity between those, so what's the migration rates between the different populations, but then also looking within a population, what is the ability of each individual population to maintain itself and its birth and death rates through the connectivity of the environment between habitats.
They're very important to the biodiversity of systems. If you look at the distribution of them in North America, I mean, they used to occur in the upper Midwest. They no longer occur there. They're on the endangered species list in Montana. And I think those are different species, but the point being the habitats that grayling need are very cold water, very clean water. And so the places that they still exist in North America are the more remote areas.
I've looked across at 16 different locations near Tulick Field Station on the North Slope.
That's nice.
From those samples, I was able to distinguish distinct genetic populations. So we call them genetic clusters, which means that those different locations are exchanging genes with each other more frequently than they are with the other populations. There's still a little bit of movement between populations, but mostly they're exchanging within those genetic clusters. And those genetic clusters are probably due to watershed boundaries, and those watershed boundaries occurred probably about 10,000 years ago, when those glaciers retreated and left those watersheds as they are.
The Kuparak River from Green Cabin Lake down to Simpson Lagoon on the Beaufort Sea is about 180 miles long or so. And again, it comes out of the foothills of the Brooks Range and then goes through the coastal plain. The different habitats may actually be what's distinguishing that lower and upper river population, if they do exist, because the habitats are different.
If you had one huge, big, like we call it panmictic population, which means that everybody's exchanging and it's just really one huge population, if you think about genetics, that would be just one homogeneous genetic population, right? When you have isolated individual populations, you have the opposite scenario where there's no movement between the populations, and you get these isolated populations where you get a lot of local adaptation going on. So the genes in this population would be very different from the genes over here, but they never interchange. If you get a local extinction over here, you then don't have that exchange of genes, that population is lost, and you get a decline in your genetic variation. But if you have some scenario in the middle where you have some isolation and some interchange of genes, that's the best scenario actually for resilience in terms of genetic variability, because you get some local adaptation which causes changes in the gene populations, but then you get some exchange too, so they share them, and then you get a lot of variability across the landscape.
The next piece would be to try to identify the movement patterns of that lower Kuparak population within the Kuparak oil field, see where those fish move, and then at least you'd have a much better definition as to when and where those two populations intermingle, if you would. They may not spawn together, but at least their range may overlap. If that's the case, perhaps the stream is big enough, and again, this is one of those pieces that nobody's done enough work on this critter or most other critters in the Arctic, but perhaps there's even a third location. Maybe there's a discrete group in the middle that lives its entire life more in the middle part of the Kuparak. So you'd have a lower population, a middle population, and upper, but We don't know that yet, but that would be my next interest, would be try to define what the lower population does.
We can't change the course of climate change. That's here. But what we can do from a management perspective is when we build roads, for example, they're planning a road out to Umiat, which is very close to my study area. We can ensure by knowing what these populations are across the landscape, for example, and what interpopulation needs might be and movement patterns from both my work and Linda Deegan's work and Jeff's work. We can then say we need to ensure that there are culverts placed in these locations and that they're proper and that we have a bridge here in this location. And just to ensure that the habitats that are critical for these fish to move to and from remain accessible.